All right, so this is Metamorphic Rocks, lesson 3, so welcome. So basically, if we look at the rock here in the picture, we can tell it's metamorphic rock, and that's because it has these kind of squiggly lines on it. So a sedimentary rock will have nice horizontal lines, and igneous rocks won't have these lines at all. So we can tell this has been squeezed by heat and pressure because the once normal straight lines have now become squished together, and so we know that they are metamorphic. So this is intrusive. So this is just a review, but intrusive rocks, they are, we know they're intrusive and they formed inside the earth, and that's because they have crystals. So we can see that there's different, minerals in there. So we can see the black, we can see the white, and so it cooled very slowly. And so intrusive rocks cooled below the surface very slowly. All right, so with a metamorphic rock, we can recognize that, like I said, with the squiggly lines, basically. So we can tell that the chemical composition has changed. Some of the minerals have morphed together, and then also any straight lines will now be curved, like you can see in this picture. So this rock did not fully melt. Part of it melted, but not all of it, and so it just partially melted. So some of the minerals melted, some of them did not. All right, there's two types of metamorphism. So there's regional and there's contact. So regional would be a whole region like mountain building, for example, like the Sierra Nevadas. Whereas contact metamorphism, it contacts the magma source. So you can see in the two pictures here, regional would be, it's occurring because of mountain building. So there's lots of heat and pressure. Remember, it's not melting all the way, maybe partial melting, but not all the way. So it has created this kind of whole region of metamorphic rock. Whereas contact will be one specific spot. So like if you go to Mount Shasta, for example, you might see some metamorphic rock right around the magma chamber. But you won't see it across the entire region. You're going to see mostly just igneous rock. All right, so the minerals in metamorphic rocks recrystallize. So before we had talked a few weeks ago about minerals will melt at different temperatures. I gave an example of a chocolate chip cookie. So the chocolate chip cookie itself, the chocolate chips are going to be melted before the chocolate chip cookie does. So let's say you leave it in the car or something. So that's the same way with rocks. So some minerals are going to melt faster than other minerals. And so that would be then a changed rock. And that's what metamorphism means, is just that it's changed. So it would be a changed rock, meaning that it's different. All right, so there's two types of metamorphic textures. So every time, when we look at igneous rocks, we look at sedimentary rocks, there's textures. And so we refer to the texture as the way it looks, not the way it feels. So there's foliated texture. So in this picture, you can see foliation is this lined banded pattern. So it's, you can see in the clearly that there's a banded pattern. So that's called foliation, when there's the lines. And that's because the crystals, they will align themselves perpendicular to the pressure. So the pressure in this case came from this direction here and this direction here. And I know that because it's perpendicular to the direction of force. So if I were to pick up this rock, or if I were to see this rock on a big section of cliff, I would know where the pressure came from in that case. All right, and then there's non-foliated. So non-foliated means there's not a banded pattern. This could be due to the fact that it's contact metamorphism, so it came into contact with something, it wasn't pressure. Or it could just be due to the fact that it only has one mineral. So like, for example, limestone it forms marble, and which is pictured on the left. And so that only has one chemical composition, so it's not going to change. It's not going to be different minerals that are forming. And then quartzite is made from sandstone. If there's any kind of round particles, so sand is round, they're not going to squeeze together into a banded pattern. So quartzite forms from sandstone, and there would be no banded pattern because the particles, the sediment is round. All right, so there's different textures, like I mentioned. So we've got foliated and non-foliated. And then we've got textures within that. So there's coarse grained, which would be very banded. And then we've got layered, and some of these would be like shale and things like that. Here's a variety of what minerals would be present, and then some of the rock names. And we'll take a look at all of these. I have a lab that we do where we look at all of these types of rocks. So we'll do that. But you can see that mostly I just want you to know the difference between foliated and non-foliated. So non-foliated, no stripes, foliated, stripes. All right, so different grades of metamorphism. So you can see if we look at shale all the way down to the rock called gneiss down at the bottom right, that's increasing metamorphism. So shale is slightly metamorphic. It is metamorphic, but it's slate that, or it's basically shale is a sedimentary rock, and it undergoes a little bit of heat and pressure, forms slate, and then phyllite, schist, and gneiss. And so that's all formed from shale. It's just different levels of metamorphism. So either really intense or like gneiss, or really lightly metamorphosized like slate. All right, and then there are different minerals that melt at different temperatures. And so we can see these different minerals as it goes through metamorphism. So we're thinking of the shale again. So back to this picture, shale to gneiss. So we can see it goes from chlorite all the way to sillimanite. You don't need to know these at all. So you don't need to memorize these or anything like that. But basically, it's just showing the different minerals that crystallize as you go through the different levels of metamorphism. And just know that there is a difference. So the more metamorphic it is, the more heat and pressure it's gone under. So it's going to, different elements are going to combine to form different minerals. All right, so regional metamorphism, like I said, is when you have a region. So you can see I've got both in this picture. So regional would be this entire area is metamorphosized. So this entire like Sierra Nevadas or coastal range of mountains are metamorphic. And then you've got contact, which would be like near volcanoes like Lassen or Shasta. You would have contact. So you probably more than likely have both types of metamorphism. You would only have contact here because the plate is splitting, so there's not pressure necessary there. But you have usually contact and regional are formed together. All right, and then contact, like I said, is just in contact. It's come into contact with magma or lava. And so it's melted slightly because of just simply getting hot. And then there's a different type of metamorphism. This is hydrothermal. So we would see this near Yellowstone, for example. So these rocks have been altered because of hydrothermal venting, so superheated water. So it's not a magma source, but it's actually just really superheated water. So think of going to Lassen, for example, and you're going to the hydrothermal pools like Bumpass Hell. So you're going to see some metamorphic rock that's metamorphosized by hydrothermal vents. So superheated water causes some of the minerals to melt. And so that would be near an active volcano. All right, and then we do have economic benefits to metamorphic rocks. We use some as ores. So remember, an ore is something that we can mine for a profit. There is some value in metamorphic rocks, just like there's value in igneous and sedimentary as well. So here's an example, a mineral source, and this is from hydrothermal vents, and this would be gold. So gold is formed, a mineral, and this is found here on this rock. It's on quartz. So those metallic deposits are from hydrothermal venting. So that would be a type of metamorphism, but that's also a mineral. And then we have this graphite. So we use graphite for our pencils. So that would be a good example of a metamorphic version, non-metallic. And we also have non-metallic. So graphite is metallic, but non-metallic things, talc, asbestos, graphite is metallic. All right, and then if we go through the rock cycles, so we've talked about all three types of rocks: metamorphic, sedimentary, igneous. So the rocks are constantly changing. They're not going and just staying as one rock. So a rock is formed, it breaks down into sediment. The sediment reforms another sedimentary rock, or maybe it melts and forms a igneous rock, or maybe that igneous rock partially melts and forms a metamorphic rock. So it's constantly changing. Rocks are constantly breaking down and forming. And here's the rock cycle. So definitely be familiar with this. It's not something that you should memorize, but it's definitely something you should know. So if you know how each of these rocks forms, then you know this chart, the cycle. You don't have to memorize the cycle because that's not going to really help you. But if you know how each forms, then you have memorized this cycle. But don't just memorize where things are, but understand sedimentary, metamorphic, igneous rock, how they form and how they would break down into something else. And like I said, then you know this whole thing. So you can see weathering and erosion occurring here. That can break down into sediment. So weathering and erosion is going to cause any rock to be a sediment. And then sediments can form sedimentary rocks through lithification. Igneous rocks, notice how weathering and erosion always points to sediments because that's what happens. Anytime something melting, it forms magma, which is going to recrystallize into igneous rock. So any kind of cooling and crystallization is going to be pointing to igneous. Any kind of heat and pressure, that's all going to point to metamorphic because that's how it forms. And that's it. So definitely know the rock cycle. Definitely understand how each of these rocks work. But like I said, you don't need to memorize the table or the cycle. Just know the process and know how each forms, and then you essentially have it memorized. All right. Well, thank you.